Okay, so we are going to talk about things that we know about our last center, which is the orthocenter. So if we're going to talk about things we know about the orthocenter, we first of all have to know what it's made from. And the orthocenter is made from the altitudes. So it's where all of the altitudes intersect. And altitudes is just another word for a height. And the main thing that we need to know about that is how to make a height. And we're going to make a height by finding two things. You need to start at a vertex, and then you need to draw the line that's perpendicular to the opposite side. And we'll do an example of this in just a moment. But when we think about a triangle, and you think about drawing the height of a triangle, if you started at this vertex, your goal is to draw a line that is perpendicular to the side across from it. And in our case, that would look something like this. And we could continue to do that by imagining that this is the bottom. And you need to draw a line that's perpendicular to the green side from this green point. And that might happen somewhere like this. And you could finish this off by doing the same thing with the last point and going to the opposite side. And you would go perpendicular in that same way so that your orthocenter would be where all of those altitudes intersect. Okay, so really the only thing that you need to know about the orthocenter is that it's made from the altitudes or the heights, and that we need to be able to find a perpendicular line. And the way that we're going to do that in just a moment is by finding the slope. And remember, slope is y2 minus y1 over x2 minus x1. And then we need to be able to find the perpendicular slope, which means that we're going to be talking about the opposite reciprocals. And now we're ready to dive into a problem. So let's say that you're given 3 points. The way that we find the orthocenter is going to be typically on a graph. So you're given 3 points. Point P is 8, 5, point Q is 1, 1, and point R is negative 2, 10. So we plot each of those points. So negative 2, 10 is way up here. That's going to be point R. We can do the same thing with point P over here at 8, 2, 4, 5. And point Q at 1, 1. We can label that point Q. And now we'll put in the segments. Whoops, we should probably use solid segments. So here are our segments, and we have made our triangle. So remember that the orthocenter is the intersection of the altitudes. And so we need to be able to find an altitude. So let's say that we started with point Q. Point Q is across from segment PR. So before we can do anything, we need to figure out the slope of PR. So we do that using our slope formula, y2 minus y1 over x2 minus x1. And when we do that, we're going to get 10 minus 5 over negative 2 minus 8. So we come up with 5 over negative 10, which reduces down to negative 1 over 2, which means that our perpendicular slope is going to be a positive 2 over 1, which means that from point Q, you're going to use this perpendicular slope from point Q. So here we are at point Q, and we're going to go up 2 over 1, up 2 over 1, up 2 over 1, and we could keep going if we needed to. And so we then connect our perpendicular line, and we can see that these two segments are perpendicular. But one altitude is not enough, so we choose another point. And let's say that we chose point R. So if we're going to choose point R, we need the side opposite point R, which is PQ. So we're going to do the exact same thing. We're going to find the slope of PQ. So to do that, we're going to look at y2 minus y1, so 1 minus 5 over 1 minus 8. And that's going to give us negative 4, that's going to give us a negative 4 over a negative 7, which simplifies to positive 4 over 7. So our perpendicular slope would be negative 7 over 4. And that slope we're going to use starting at point R. So we touch point R, and we need to go down 7 and right 4. So we drop down 2, 4, 6, 7, 1, 2, 3, 4. And you could repeat that again and say 2, 4, 6, 7, 1, 2, 3, 4. And we could connect these and make our line. So we start at point R, and we come straight down. And you don't have to go out to this point out here. You can, so that you have another line to connect just to make sure that you've connected your points correctly. And we can see that these intersect, but just for practice of doing the altitudes, we're going to do the last one. So that's starting at point P. We need to find the slope of RQ. So over here, we look for RQ's slope. And that's going to be 10 minus 1 over negative 2 minus 1, which is going to give us 9 over negative 3, or negative 3 over 1. And again, we need the perpendicular, so that's going to be a positive 1 over 3. And that we're going to use starting from point P. So if you're at point P and you want to go positive 1 and positive 3, that's taking you further away from your blue line over here. So the only way to go positive 1, positive 3 is to go backwards. So down 1 and back 3. Down 1 and back 3. And you could continue that so that you know that you're in a straight line. And then we're going to connect them. See that they formed a right angle. And now we can find the orthocenter, which is this point in the middle. So our orthocenter is going to be the point 1, 2, 1, 2, 3. So the point 2, 3. And that's it.